Artificial intelligence looks like software, but software does not control AI. Infrastructure does. And the future of AI may be shaped less by the smartest model and more by the companies controlling the chips, data centers, cloud systems, and power behind it. Artificial intelligence is usually discussed at the surface level. A chatbot, an image model, a coding tool, a recommendation engine. But these are only interfaces. The real system sits underneath. Chips, factories, data centers, cloud platforms, power grids, networks. AI is not just a software category. It is an infrastructure stack. And once you see that stack clearly, the key question changes. The question is no longer only who builds the smartest AI model. The question becomes, who controls the infrastructure that makes advanced AI possible? To answer that, we have to break AI infrastructure into layers. The first layer is semiconductor design. Modern artificial intelligence depends heavily on GPUs and specialized accelerators. These processors perform the massive parallel computation required by neural networks. That makes chip designers extremely important. The most important company in this layer is NVIDIA. Its hardware powers a large share of modern AI training and deployment. This gives NVIDIA enormous strategic weight. But designing a chip is not enough. The chip must still be manufactured. That brings us to the second layer, semiconductor fabrication. This is one of the hardest industrial processes in the world. Advanced chips require extreme precision, advanced tools, clean room production, and huge capital investment. Very few companies can manufacture the world's most advanced processors. The most important one is TSMC. That means a large part of the AI economy depends not only on who designs the chips, but on who can physically produce them. This makes manufacturing a control point. Now move to the third layer, data centers. A GPU in isolation does nothing. It must be deployed inside a facility with power, cooling, networking, and operations. Modern AI data centers are not ordinary server buildings. They are high-density compute environments designed around electrical load and thermal control. As AI models grow, these facilities become more important. Whoever controls data center capacity controls part of AI's physical foundation. Then comes the fourth layer, cloud platforms. Most companies cannot build global AI infrastructure from scratch. They rely on cloud providers. That means firms like Amazon, Microsoft, and Google do more than rent servers. They control access to large-scale computational environments. That gives them enormous influence over who can build, deploy, and scale AI quickly. Cloud control is infrastructure control, and infrastructure control becomes market power. Then there is the fifth layer, energy. AI systems do not run only on chips and servers. They run on electricity. Large AI clusters require huge amounts of power. That means AI growth depends on grid capacity, utility access, backup systems, and cooling efficiency. This is why power is now part of the AI conversation. Without enough electricity, AI does not scale. So who controls AI infrastructure? Not one company. A narrow set of companies across multiple layers. NVIDIA shapes hardware access. TSMC shapes manufacturing access. Cloud providers shape deployment access. Data center operators shape compute environments. Energy systems shape scaling limits. This is not a complete monopoly. It is something more complex. A concentrated infrastructure network. A small number of firms controlling essential bottlenecks in a system that the wider AI economy depends on. And that concentration matters. Because infrastructure power is different from product power. Products change fast. Infrastructure changes slowly. If a company controls a product category, competitors can appear quickly. If a company controls a critical infrastructure layer, its influence lasts longer. That is why AI infrastructure matters so much. It sits below the application layer, and whatever sits below the application layer shapes everything above it. This also explains why the AI race often looks like a software race, but behaves like an industrial race. The public sees models. The real system runs on chips, fabs, cloud systems, data centers, and power. That is where the bottlenecks are. That is where the leverage is. And that is where strategic control begins. This has three major consequences. The first is concentration. If only a small number of firms control the most important infrastructure layers, then much of AI, economic value will flow toward them. The second is dependence. Startups, enterprises, and even governments may build AI products, but still depend on infrastructure they do not own. The third is geopolitical risk. If advanced chips, cloud systems, and manufacturing capacity are concentrated across a small number of firms and geographies, then AI infrastructure becomes a strategic issue, not just a business issue. That is why governments care so much about semiconductors, data centers, and cloud systems. They understand that future economic and technological power may depend on access to AI infrastructure. This also changes how we should think about AI winners. The winners may not only be the companies with the most impressive models, they may also be the companies with the strongest infrastructure position, the ones with chip access, the ones with cloud scale, the ones with energy relationships, the ones with manufacturing leverage, the ones controlling the bottlenecks. This is why the question, who controls AI, is often too vague. No one fully controls AI as an idea, but a relatively small group of companies controls large parts of the infrastructure on which advanced AI depends. And practical power lives there, in the hardware layer, in the manufacturing layer, in the data center layer, in the cloud layer, in the energy layer. These layers are linked. Control over one layer strengthens influence over the others. If you dominate chips, you shape compute access. If you dominate manufacturing, you shape hardware supply. If you dominate cloud distribution, you shape deployment. If you secure power at scale, you shape future expansion. Together, these firms do not merely support AI, they define its industrial foundation. So who controls AI infrastructure? The answer is layered. NVIDIA controls a major share of advanced AI hardware design. TSMC controls a major share of advanced semiconductor manufacturing. Major cloud firms control access to large-scale AI deployment environments. Data center operators control physical compute capacity. Energy systems determine what can actually scale. That means AI infrastructure is controlled by a narrow system of semiconductor, cloud, compute, and power concentration. And that system is becoming one of the most important power structures in the modern world. Because the future of artificial intelligence will not be shaped only by software breakthroughs. It will be shaped by who owns the systems beneath the software. AI at scale is not just an algorithmic achievement. It is an infrastructure achievement. And infrastructure, once concentrated, becomes power.